I'm going to talk about composite functions, which I think confuse a lot of people. So hopefully I will be able to explain it in a way that might help to make it a wee bit clearer for you. Let's think about two functions. We've got f of x equals x squared plus 1. And we've got g of x equals 3x minus 6. Okay, so we'll think about what that means. What that means is that if you apply the function f to x, or to anything, what you do is you take that x, you square it, and you add 1. So for instance, if you didn't put x in there, if you put a in that function, you take whatever you put into the function, that's a in this case, then you are squaring it and adding 1. Okay, so you're just taking, this is the definition of the function here. So whatever you put in, you square it and you add 1. F of b, of course, is, well, whatever you're putting in, so b squared, and add 1. Okay, what would happen if you put in p plus 1? Okay, so then you've got, well, the definition of the function is whatever you put in, squared, and then add 1. So whatever you put in here is p plus 1. Okay, you've got to square that, because that's what the function, the definition of the function tells us to do. Take whatever you put in, square it, and add 1. So we're taking whatever we put in, squaring it, and adding 1. Okay, and then we would multiply out the brackets and what have you, just to make sure that it was in its simplest form. Okay, so it doesn't have to be x that you put into the function. Whatever you put in, you square it and you add 1. Right. Similarly, g of x. Okay, we've got g of x is 3x minus 6. So g of a is, well, 3 times whatever you put in, so it must be 3a minus 6. And let's think about what g of q plus 4 would be. Well, it's 3 times whatever you put in, and that was q plus 4, take away 6. Alright. And then we'd multiply out the brackets just to keep it tidy. 3q plus 12 minus 6, which is 3q plus 6. Okay, right. Let's think about then what we do if we have f of g of x. The first thing we need to do is to calculate g of x, because what we're doing here is we're applying the function f to g of x. And in order to do that, we first of all need to know what g of x is. Well, we know that. We've got it written down up there. G of x is 3x minus 6. Okay, I don't think anybody would argue with that. G of x, 3 times whatever you put in, x, minus 6. So then we need to think about what f of g of x is. Well, that must be f of 3x minus 6, because that's g of x. Right, so f of 3 of x minus 6. Well, we did a little bit of that up here. F of p plus 1 was p plus 1 all squared plus 1, because that's the definition of x. You take whatever you put in, you square it, and you add 1. So here we're putting in 3x minus 6. So it must be that we take whatever we put in, that's 3x minus 6, we square it, and then we add 1. That's the definition of f of x. Whatever you put in, squared, plus 1. And then we would multiply out the brackets to keep that nice. 6 to 18, 36. X plus 36 plus another one, so 37. Right? Let's think about g of f of x. you could pause the video and have a try before we go through it. Right, are you back? Let's have a look. What we're doing here is we're applying the function g to f of x. So to work out what to put into g, we first need to work out what f of x is. Well, we know that. We've got a definition of f of x. F of x is x squared plus 1. Okay, so we take whatever we put into f, we square it and we add 1. So g of f of x must be g of x squared plus 1. Right, now what does g mean? The definition of g, let's have a look up here, the definition of g is 3 times whatever you put in minus 6. So it'll be 3 times whatever we're putting in. Well, we're putting in x squared plus 1. And then we're subtracting 6. And that's your answer. We just need to tidy it up. 3x squared plus 3 minus 6 is minus 3. So hopefully that makes sense, and composite functions are a little bit clearer than they were. We'll have a look at a couple of other examples. You might have a function like f of x equals cos x and g of x equals 3x. They work exactly the same way. F of x, or f of whatever you put into the function, is cos of that. Okay, so if you put in a to the function, f of a, it's just cos of a. If you put in 30 degrees to the function, it will be cos of 30 degrees, which I'm sure you know is root 3 over 2. That's not very good of root, is it? Root 3 over 2. Okay. And if you put in y minus 2, it would be cos of whatever we put in, which is y minus 2, cos of y minus 2. Okay, so again, whatever you put in, you take the cosine of it. So let's have a look at what f of g of x would be. We are taking f of g of x. Now, what is g of x? Well, g of x is 3x. If we put x into there, we get that. So f of 3x, we know what f of something is. It is the cosine of whatever that something is. So we're putting 3x into f of x. So we just take the cosine of 3x. So it is cos 3x. Okay, and we'll do it the other way around. We'll g of f of x. Well, first we need to work out what f of x is. So we know f of x is cos x. Okay. So g of f of x must be g of cos x. Okay. Now we know what g of anything is. G of something, whatever you put into it, is 3 times that. So it's 3 times what we're putting in, 3 times cos x. So we'll have a look at another one, a little bit more fiddly, but it works exactly the same way. Let's say that f of x equals x squared plus 4x. Okay, so we've got 2 x's here, but that's okay, because whatever we put into that function, we square it, and then we multiply it by 4, and then we add the two things together. So f of, let's say, a would be Well, what are we putting into the function? We're putting a in, so we need to square a. That's what we do to it. And then we need to add on 4 times a. Let's do it with a number. Let's put in 2. F of 2. Well, what we're putting in is 2. Okay, so for every occurrence of x in here, we need to substitute 2. So first we square it, so we've got 2 squared. And then we add on 4 times it, whatever we're putting in. So we've got 2 squared plus 4 times 2, which is 4 plus 8, and it's 12. So that's how f of x works, where we've got x appearing more than once. It means every time we see an x, we replace it with the thing we're putting into the function. Let's go for g of x equals 6x. Okay, so that's the definition. Whatever we put into g, we just multiply it by 6. Let's do f of g of x. Okay, we know that g of x, so we're putting x into the function g, well, that will give us 6x. So we need to take f of 6x. So let's look back at the definition of f of x. What do we need to do first? We take the thing we're putting in, which is 6x, and we square it. Remember those brackets, make sure you square the whole thing. And then we add on 4 times whatever we're putting in, which in this case is 6x. And then we multiply it out to keep it tidy. Remember, we're squaring all of this, so we have to square the 6 and the x, so 36x squared plus 4 times 6x, which is 24x. Okay, let's look at doing it the other way around, g of f of x. So the first thing we need to do is to work out what f of x is, because that's what we then want to put into the function g. So f of x, we know, we defined f of x as x squared plus 4x. So x squared plus 4x. Okay, so that's what f of x is. So g of f of x is g of x squared plus 4x. Okay, so this is what we're putting in to the function g. Now, what does g do to whatever you put in? It just multiplies it by 6. It takes whatever you put in and multiplies it by 6. So we've got 6 times whatever we put in, which is x squared plus 4x. So that is 6x squared plus 24x. And that is your answer.